Dr. K.K. Sari. I welcome you all here to share my views. First of all, I just want to wish you a good afternoon and very nice day. And I like to have a patient hearing from your side. The topic is quite new. Today I am going to share my works on memristors and chaos theory in communication engineering. To be specific, we have to talk about that the communication system has to be very, very secure. Otherwise, nowadays, people are copying the material at the transmitter level, at the media level, at the receiver level. And this is my brief resume. I have a 25 years of technical teaching experience, serving at a various posts. At present, I am professor in Dronacharya College of Engineering, Gurgaon. And these are the contents which I am going to share with you. And today I am going to deal with the basics of the memristors. Tomorrow I will deal with the basics of the chaotic theory. Then I will mix this memristor and chaotic theory to generate these chaotic generators at the transmitter level, at the receiver level, so that communication system should be more secure. But then now the question arises, in a basic communication system, there is a transmitter, there is a media, there is a receiver. And in between this, we noted that the input of the transmitter is never equal to the output of the receiver. Why? Noise is one of the factors, provided the different techniques are also one of the factors. So today I am just going to deal with these memristors. And now the question arises, what is this memristors? In 2012, I got an opportunity to visit Las Vegas in USA. There I find out that in University of Nevada, a lot of work is going on the memristors. These memristors are basically, you can say, memory plus register. Is yet a quite unknown circuit element, though equally fundamental as resistors, capacitors and coils. It was predicted from theory arguments nearly 45 years ago, but not realized as a physical component until recently. The memristor shows many interesting features when describing electrical phenomena, especially at small scales, and can in particular be useful for bioimpedance and bioelectricity modeling. It can also give us a richer and much improved conceptual understanding of many such phenomena. And the question arises, what is it? Gentlemen, it is the world's smallest memristive switch, an information storage device of an unlimited capacity, a concentration of memory registers. It is a passive two-terminal circuit element that maintains a functional relationship between the integral of current and voltage. As per this memristors are concerned, memristors are basically a fourth class of electrical circuit joining the resistor, the capacitor and the inductor that exhibit their unique properties primarily at the nanoscale. Theoretically, memristors, a concentration of memory plus resistor, memory resistor, are a type of passive circuit elements that maintain a relationship between the time integral of current and voltage across a two-terminal elements. Thus, the memristor resistance varies according to devices memristance function, allowing a very tiny red charges across access to a history of applied voltage. The material implementation of memristor effects can be determined in part by the presence of hysteresis, which, like many other nonlinear anomalies in contemporary circuit theory, turns out to be a less anomaly than a fundamental property of circuit. And this Professor CHUA is the father of memristor. And here I am just point out that in 1971, Professor Leon CHUA, he is a professor in University of California in Berkeley, USA. He have given the idea of memristor in 1970s. Now in 2015, now the idea of the memristor has practically implemented, and the HP lab has given this idea, but still lot of work has to be done. Before this, I want to tell you a very, very small story. While doing a practical in the class of the Professor Leon CHUA, one of the students pointed out, sir, we cannot get left hand side is equal to right hand side for any theorem, whether it is a Kirchhoff voltage law, whether it is a Kirchhoff current law, whether it is a Thevenin theorem, whether it is a Norton theorem, in summation, or you can say law of conservation of energy. Summation of any equation cannot be zero. Now they have done a practical number of times, but still they are not able to prove left hand side is equal to right hand side, because RLCs are there up to the decimal 0.99, or you can say after that you sum it out. Mathematics can easily prove V is directly proportional to I. What say do they? V is equal to Ri. R is constant of proportionality. Mathematician can take R is equal to 1, R to any value. But for us engineers, we technocrats, we cannot able to still date, able to prove it, justify it, any theorem. And I was also a student of engineering. I have also proved the theorems. Now I am teaching to my students. We prove them theorem. But actually, if we take reading seriously, digitally or analogically, or manually, you can say digitally or manually, we will find out that any theorems, they cannot be proved it till date. Then this Professor CHUA got an idea of memristor. And Professor CHUA, I haven't given this diagram, kindly pay attention to this one. This basically two basic physical laws. One is rate of change of charge per unit time, that is current. Another is voltage change of flux with respect to time. And you can say I current is there, charge is there, and magnetic flux is there. So you will find out different laws: inductance, capacitance, and resistance. It has been given here. But can you tell me, is there any relation between charge and magnetic flux? Till date, if you left this memristor, if you left the work of Professor CHUA, you will find out there is no relation, no direct relation between a magnetic flux and charge. So Professor CHUA give a direct relation between a magnetic flux and charge, and he termed it memory plus resistance. He termed it memristors, and this rate of flux with respect to charge, d phi by the change of flux by charge, is termed as a memristors. When this concept is added into those laws, then the left hand side is proved as a left hand side is proved of an equation is equal to right hand side, while taking a reading of all those theorems, all those practicals. Means basic parameter are RL and C. With RL and C, we are not able to justify any theorems, whether it is a Ohm's law or whether it is a Thevenin theorem or Norton theorem or any other theorems. This is the basic work given by the Leon CHUA in 1970, and till date, lot of work is still required to be done in it. Similarly, neurons are there from medical science and technical science, neural networks, genetic algorithm, fuzzy networks. This diagram shows that there is a near about same function in neuron synapses as well as the memristors. Means these are kind of registers which have the memories, and they can store the data for a fraction of a second or for a certain period of times. Now, to in fact coming to the basics of the memristors, you find out like this, that we know it very well. Resistor, capacitor, and inductors are the basic passive elements, and up to till date, fourth element is not there. But now Professor CHUA has proved that there has to be fourth element, and this element is termed as memory or memory plus resistor. If this element is there, only then the already other theorems are proved technically. And as per this diagram is concerned, again, this resistance, inductance, and capacitance and memristor are there. Professor Leon CHUA got a IEEE Christoph Award for his discovery of the memristors. And as per the Professor Leon CHUA, all the IEEE electronics, electrical, computer, and other engineering which are working with the basic spade work of resistance, inductance, and capacitance, these textbook has to be changed. And Professor Leon CHUA is rightly, until unless we add this memristor into the very basic concept of the engineering, we cannot technically prove anything, we cannot design anything. If we are designing, we know it that the law of conservation of energy is not maintained there. So in coming time, I also agree that all those IEEE textbooks has to be changed, and RLNC plus memristor has to be added there. Now, the very basic thing is, can you think over it, that at present, can any engineer, basically electronic engineer or electrical engineer, computer engineer, can you think when we can change a transistor or we can replace a transistor with some other components? Can we design any appliance that learn from its experiences? Can you think over it? We have to design. We want in future, we want appliance which can learn from its mistake, which can learn from its experience. And third thing, can you hope on one day we have a computer that processes information in the same way as the brain? I would like to repeat this statement again. Can you hope one day we have a computer that processes information in the same way as the brain? At present it is an idea, but with the Memristor it is possible. This I am going to try to explain in my coming slides. So the very basic thing is there is a no basic relation, no direct relation between flux and charge. What if we could create a processor with a basic building block which acts as an infinite non-volatile memory, logic circuit and switching circuit all at the same time? I repeat, logic circuit and switching circuit all at the same time. What if you could suddenly shut down your computer and then restart it to find all your files and settings just like they were before? This is the basic point on thing if you want to understand the memristors. The memristance. A memristor, once again, a concept is just visualized in this manner. A memristor is a semiconductor whose resistance varies as a function of flux and current. This allows it to remember. What I want to say? It allows to remember what has passed through the circuit. And this concept is termed as memory plus resistance. Means it allows to remember what has passed through the circuit. And this is the basic idea visualized of the HP Labs Memristor. And now we just want to have a small mathematics. The memristor is a two-terminal, variable resistance, which resistance dependent upon the magnetic flux. And you know it very well that magnetic flux is the integral of voltage. It is, and you see this relation. This is the relation of the memristors. Change of flux with respect to charge. And you know voltage is flux by time. And current is your charge by time. If we substitute these values, these three equations from previous slides, we get it like this. We get an equation like this, means relation between a voltage and current with respect to the memristors. Now this is the diagram. If you pay attention to this diagram, you will be able to try to understand that what actually this concept of memristor is there. From the symmetry diagram shown in this figure, we see how the memristor finds its natural place in the circuit theory along with 5 other combinations of pair of circuit variables. With this simple diagram in front of us, one might wonder why it took so long until the memristor was identified. From this diagram it is proved that from 1970 to 2015 still memristor required lot of things to be explained. After around 40 years, the idea was given in 1970. After around 45 years in 2010 onward, now the actual work has been started on the memristors. And from the diagram you can verify easily. Charge is there, voltage is there, current is there, and magnetic flux is there. And until unless other than the memristor, there is not even a single relation between charge and flux. The same diagram, it also shows in a very simple manner. Current and voltage, we know the relation is there. That is a Ohm's law. V is equal to IR. And for a capacitor, we also know C is charge by voltage. And inductor, we know phase by current. Now, as per the fourth quadrant law, you see, is there any relation between charge and phase? This relation is termed as memristor, and it was given by the CHUA. Now, lot of work is going on, and number of memristors are already designed. Again, as per this diagram is concerned, this diagram mathematically proved that until unless we involve a relation between flux and charge, we cannot justify all any theorem. Technically, we cannot design them accurately. And this is the symbol, standard symbol for representing a memristor in an electrical circuit. It is a two-terminal device showing a variable resistor. Now the very basic question is asked. We consider RLC as the basic passive components. Why should we consider memristor as a fundamental circuit element? What is the property of the memristor which qualifies it as a fundamental circuit element? Why do we include R, L and C plus memristor, and why do we consider them as basically a fundamental circuit elements? Kindly pay attention here to this diagram and you will find out their colorful lines. Blue represent resistor, red represent capacitor property with respect to current and voltage, and green represent inductor. And fourth one is memristor, that is purple. From this diagram, one thing is very, very clear, that blue, red and green, resistor, capacitor and inductors, they cannot duplicate the purple line in any combinations. You take any combination of RLC, you will find out that purple is not duplicated by RLC combination, that is blue, red and green line. Hence, it is a very fundamental circuit element. It has to be included. There is no other solution if we maintain the law of conservation of energy. And what does it mean? It means the image to the left, memristor fill a previous gap in our knowledge of electronics by providing a passive component which relates flux to charge. And this is the concept. This work has been done in China, the hardware and like this. The upper one person is concerned of Professor Leon Sua's basic circuit, which is a design which approved the memristor, and the hardware is designed like this. This I have taken from the courtesy from this copyright Think Art Lab ISN 2041-4358. Now I want to have the basic question rise. What is the, since we consider RLC as the basic passive elements, what is the analogy between resistor and memristor? If you find out resistor is analog with the example of a pipe, I would like to explain that how the resistor works and how this memristor works. A resistor is analogous to a pipe that carries water. If water is analogous to charge Q, input pressure is analogous to voltage V, and rate of flow of water current I, then flow of water is faster if pipe is shorter and has a large diameter or has a large diameter. The same thing you compare with this memristor. Memristor is analogous to a special kind of pipe that expands or shrinks when water flows through it. If water pressure is turned off, pipe will retain its most recent diameter until water is turned back on. This is the basic property of the pipe, and you can say it retains the water flow through it. Thus, it is a resistor with memory. From this very simple example, it is proved that memristor is a resistor, that type of resistor which carries the memories also. And in 2008, Hewlett-Packard Laboratories, it proved it given a model of memristor using a thin film of titanium dioxide. In October 2011, the same team said that technology should be commercially available within 18 months. But till date, we do not have a perfect memristor satisfying all the conditions, but work is still going on. The device developed by HP Lab consists of 50 nm thin film of a titanium dioxide with 5 nm electrodes on either side. There are two layers of the film, one of which is oxygen depleted. Now from this cross section, one thing is there, that an illustration of the HP memristor is shown in figure. This way of illustrating memristors as a component separated in two parts is very useful to understanding the basic principle. The memristor consists of one part that conduct current well, it is termed as a doped part. And one part that is much poorer electrical conductor, that is undoped part. The total resistance, or strictly speaking, the memory resistance of these two component system is the sum of the doped and the undoped part. What makes this system a memristor? The question arises. What makes this system a memristor and not a resistor is the presence of a dynamic state variable, defining the boundaries between the two parts with high and low conductance. I would like to repeat it here. What the system is a memristor, what makes this system a memristor and not a resistor is the presence of a dynamic state variable. Kindly pay your attention, that is the presence of a dynamic state variable defining the boundary between the two parts with high and low conductance. The state variable, in this case W, describe how the memristor of the element evolves with time. For this particular HP memristor, the state variable W is proportional to the electric charge Q. Now in my previous slide, this one, I say that there are two layers of the film, one of which is oxygen depleted. And what is this basic idea of the oxygen is, the oxygen depleted spots acts as a charge carrier and drift when an electric field is applied. It means changing the combined resistance of the two layers, and it can be moved back by introducing a reverse flow of charge, which causes the device to return to its initial state. The memristor will maintain its configuration if the current is cut off, making it a more robust memory solution compared to the device currently on the market. Now this is a typical behavior of the memristor. The memristance of the memristor depending on the amount of electric charge that has passed through this device. And you kindly pay attention to this curve. It is an example of an ideal model of a memristor as shown in the figure. The hysteresis loops are very valuable when memory resistive systems are to be identified, and the loops normally run through the origin in an IV plot. This behavior can be sent to rise from when you can take it as V is equal to 0, then I is equal to 0, and vice versa. Means if I is equal to 0, then V is equal to 0. This fact further underlines that memristor is not an energy storage device. The hysteresis loops are formed since the current through the memristor does not vary linearly. The hysteresis loops are formed since the current through the memristor does not vary linearly with the applied voltage, unlike a resistor that follows a Ohm law. And I would like to again repeat these few lines, that when V is equal to 0, then I is equal to 0 and vice versa. And it further underlines that memristor is not an energy storage device. The hysteresis loops are formed since the current through the memristor does not vary linearly with applied voltage, unlike a resistor that follows a Ohm law. Now these are the few basic properties of the memristor. They have developed in different stages, and mathematically formulation is given by the Dr. CHUA. On April 30th, 2008, a team of at HP Labs, the scientists who have actually designed this idea, designed a memristor, is a Stanley William, and he discovered of a switching memristor. It achieves a resistance depending on the history of current using a chemical mechanism. The HP device is composed on a very thin film of titanium dioxide film between two deuterium electrodes. Now if you want to understand this memristor theoretically and practically with the taking the example, the pipe model is a very good example to understand this memristor. You kindly pay your attention here. There is a hollow piston is there, and these are the few diameters A and small a like this. If we go back to our water analogy of the memristor, as it is shown in this figure, a DC, take it as a water, a DC, take it as a water, a DC current will push the piston only in one direction all the time, making the piston reach one of the ends of the system, and consequently the memory resistance then saturates. This means the apparent resistance, that is the memory resistance of the pipe system, does not alternate dynamically with time, which is required for the device to behave as a memristor. Instead, the memory resistance is time varying during the short initial period as the piston is being moved, and thereafter the memristor degenerates to an ordinary resistor as the piston reaches either side of the water pipe. It makes very much clear that what is the basic idea and how this memristor works. Now, we have done so many slides up to now. In summarize, if I take it like this, that what are the basic memristor properties? The first property is that it is an AC element, not DC. Thing has to be very much clear. Number 2, it is a no storage of energy. Number 3, 2-point terminal circuit element. Number 4, pinched hysteresis loop in the current and voltage plane. Next one is positive or negative differential resistance, and it have no linear charge and flux curve. It explain it. It have explanation for charge and flux curve, that is non-linear. Low frequency property and frequency dependent memristor, and typically only apparent at small scales. And these are the few facts till date. I got the data from here. In April of 2010, HP Lab announced that they had created a memristor with a switching speed of about 1 nanosecond, approximately 1 gigahertz, and a footprint of 3 into 3 nm. Since then, they have created small sample devices capable of containing 12 GB of data per square centimeter and are looking to increase that to 20 GB by 2013. And this will go on increasing with the improvement in the design of the memristors. Then you can assume that how the data will be stored and at what capacity is possible. And these memristors has true potentials. The slides are self-explanatory. Basically, the true potential of the memristor lies in the fact that they are capable of having a dozens, if not hundreds, of different states. And coming time, there might be hundreds also, but at present, capable of having a dozens, as you can think yourself. It is not an easy thing. It is not a small thing. Instead of just the two that we have coming to associate with the computing. In computing, what we are doing? We are just dealing with the two states, 0 and 1. Besides 0 and 1, in between, if we have number of states, then you can assume where this computing science, where the information technology IST will go. And the communication will advance to a stage at present we cannot even think about it. This is the true potential of the memristor, that we can have more than 2 states, even at dozens and in the hundreds, and coming time so many. And at present we are only doing 2 states, 0 and 1. Up, down, positive, negative. And another is memristors are also capable of performing logic functions, digital electronics, which means that the current compartmentalized structure of the computing could very well be on its way out, as we create devices capable of both strong and processing data in the same space. And this slide shows the milestones in the history of memristors. In around 1970, Professor CHUA, Leon CHUA, professor from University of California, Berkeley, USA, has given a idea in one of the research paper, and nobody has taken it seriously. But with the coming time, in and around 2006, HP lab intensely reduced the memristor in practice. And in 2008, in a very prestigious science journal, Nature published, HP find that memristor exists. Now you can see yourself, in 1971, Professor Leon CHUA of University of California, Berkeley postulates the basic idea of the memristor and says there is a fourth element exists. And in 2008, it has been proved that it is actually exists. And in 2010, there even in the 2015, memristors are there, but still date, as per my knowledge is concerned, lot of work is still required to be done, and it is not standardized. One of the main problem in the memristor is that we do not have standards. Everybody is talking about memristor. Number of firms are working on the memristors, but where is the standard to compare with them? In coming time, this will be also solved. And one thing more, when the idea comes in 1970 and now in 2015 also, why the development is so late? What is the reason behind it? Nowadays, every scientist, every technocrat, every mathematician is asking to itself, why it has taken so late? Why it has taken so much time? And the reason is very, very simple, because it is on an atomic scale movement. It is a nanoscale. It is not that easy things. That is the reason that it has taken so late. And now the question arises, what set memristors apart than the others? There are a few basic properties which is proved which sets the memristors apart away from the other electric and electronics component. In conventional devices, there is only 0 and 1. But memristor can use anything between 0 and 1. 0.3, 0.8, 0.5, 0.9, and like this. At present, we are using only two states, 0 and 1, and the complete system has been built over it. Can you think over it? Can it be 0.3, 0.31? Can in coming time 0.33? Can in coming time 0.333? So how many states are there? The complete communication, the complete information technology, the complete hardware and software will be changed if we are able to build a memristor with at least 3 or 4 states only. With 2 states, 0 and 1, we have achieved so much. With 3 and 4 states, with dozens of states, with hundreds of states, with thousands of states, we can simply, as an engineer, we can assume that what would be the advancement in the communication and other fields. And second one is faster than flash memory. Allow digital cameras to take picture with no delay in between. This is not a small achievement. Another is innovating technology due to the fact that it performs better than the smaller it becomes. Means more the nanotechnology idea, more it's smaller, more faster, and more better it performs. And these 3 are the major facts which set memristor apart from it. And nowadays a lot of work is going on in the memristors. Recently I was invited to chair a technical session in Thailand. There also I have discussed with those scientists, engineers coming from the Thailand, and people, they are putting a plants on the memristors and they are thinking and working about the memristors. And as per our country is concerned, I think still we are not able to make one IC properly. And you will be astonished to know that we are getting the electronic component from Korea, Japan and other countries, and from Thailand also. And these are other few facts. Another is, by changing the speed and strength of the current, it is possible to change the behavior of the device. And at present, nowadays in curricula, in syllabus, we are not dealing with the speed of the current and strength of the current. Strength we are taking, but we are not dealing with the speed of the current. If we are able to deal with the speed and strength of the current, we will find out that it will be possible to change the behavior of the devices. A fast and hard current causes it to act as a digital device. A soft and slow current causes it to act as an analog device. Mean the things is a fast and hard current digital device is there, speed is low, we can act as an analog device. This will be possible with a memristor and it has been proved. Technically proved, mathematically proved, and work is going on it. As per the benefits of the memristors are concerned, the benefits are, number one is provides greater resilience and reliability when power is interrupted in data centers. Combine the job of working memory and hard drives into one tiny device. Have a great data density, faster and less expensive than MRM. Use less energy and produce less heat. Producing a less heat is also one of the very important factor in devices nowadays. Would allow for a quicker boot up since information is not lost when the device is turned off. Operating outside of 0 second and 1 second allow it to imitate the brain function. With the memristors, now scientists are able to think over it that we can at least copy brain to some extent. As soon as the memristor will be developed properly, we can at least simulate the brain also. And these are the few benefits of the memristor again. Quicker boot up since information is not lost when the device is turned off. Uses less energy and produces less heat. Do not consume power when ideal. As I told you, it is faster than the flash memory. Innovating nanotechnology due to the fact that it performs better the smaller it becomes. Memristor can perform uniform universal Boolean logic without having a NOT, NAND and NOR. Now we can think over it. Is it possible to perform a uniform universal Boolean logic without using NAND, NOT, NAND and NOR? I do not have any idea. But with the memristor it is possible. Now we come to the applications of the memristors. Application non-volatile memory. It is a very important fact. Another low power and remote sensing. Crossbar latches as transistor replacements. Analog computation circuits with mimic neuromorphic and biological systems. Programmable logic and signal processing. Memristor can also perform logic and it can act as a microprocessor. These are the few limited applications. With the coming time, as the memristors will be designed and the lot of improvement will be done, it is going to interfere, it is going to play a vital role on all the gadgets. In the medical science also, as well as in the communication and all branch of engineering, even in the civil and mechanical engineering also. So its application goes on increasing with its design. There is a main, normally I met number of scientists, engineers, they used to discuss what is the ultimate goal. What is the ultimate idea by which this future technology significance? And what is the future technology significance of memristor? We now, with the advancement of memristor, we are able to hope that one day, in a coming time, in our life itself, we will be able to design a computer that processes information in the same way as the human brain. Now it is available, now it is achievable. Otherwise, up to 2000 or 2005, it is very hard to give this idea. Are we able to design a computer same like a human brain? No. That time do not have an idea. But now it is possible that with the advancement in the memristors, our computers will be able to process the information just like a human brain. And another one is, as I told you, this will like this, could lead to the replacement of the transistor. It will be a great major achievement in the field of electronics and electrical engineering. At this time, we spend lot of circuitry keeping a transistor in active region. It switch on to saturation or goes to the cutoff region. And thermal runaway heat up system has to be there, biasing has to be done there for the transistor. But if we are able to replace the transistor with a memristor, then circuitry will be less and results are far, far better. And another thing is HP lab has proved that with the Memristor we are able to design, we are able to design appliance which learns from its experience. It means appliance from its mistake, appliance from its working, appliance what from the last experience, they can improve their working like this. These kind of appliances will be available in next 2 decades, I think. And it could be put in a cell phones or a monitoring device to track pollution and other things in the environment. Used in a common devices for an unbelievable storage. Another is the camera can take days worth of video with storage the size of an average thumb drive. Now comes the future scope again. Researchers believe that discovery will pave the way for instant on PCs, more energy efficient computers and new analog computers that can process and associate information in a manner similar to that of the human brain. But the basic idea, the basic work of the Memristor, that it is going to find applications in the different parts. It is going to find the application in all branch of engineering, plus medical sciences, plus nanotechnology. But the main achievement with the Memristor is that we will be able to design something that will be equal to our human brain. Now come the questions of the limitations. Not perfect yet. I am really sorry to say that Memristor in our country is just on paper, just a theoretical concept. Because in nanotechnology itself, we have not advanced to the stage which we have to be. In this ICs are concerned, we are not able to design the ICs which is required. Even the small components, for a small component with a particular specifications, we are looking towards the other countries. And those very, very small countries like Thailand, Korea and Japan, they are supplying the electronic components to us with a perfect specification, with a perfect specifications. And as per the talking about the Memristors, lot of work is going in the other countries. And since in other countries also, as per my knowledge is concerned, since thrice I have visited in 2014 and as well as in January 2015 also in Thailand, there a lot of work is going on the Memristors, and I have interacted with those scientists, those teachers. They say it's not perfect yet. Though hundreds of thousands of Memristor semiconductors have already been built, there is still much more to be perfected. Non-availability of any design standard further increase the problems. And one of the scientists, they told me that the different countries having a different ideas about the specification of the Memristor, and everybody is independently going towards the research work. So it is very difficult to standardize it, because nowadays the basic standards are not available. Maybe in the coming time all those countries who are working in the Memristor, they will sit down and fix the standards, and then accordingly like this they will work on it. Wait. Now kindly look toward this figure. This is the first realized Memristor produced in the HP lab. 17 nano Memristors are shown in parallel. You can count over it. The image was produced by R. Stanley William of the HP lab, and it is reproduced with the permission from R. Stanley William. As I told you in my last previous slides, that R. Stanley William has first of all given this actual concept of the Memristor on titanium oxide. These are the references, and before this, before saying a thank you, I would like to say that emerging technologies provide a unique opportunity to introduce science within education. The development of Memristor the fourth passive component type after registers, capacitors and inductors, along with other solid state memory devices, take us one step further to creating cheap, powerful, distributed solution for sensing and processing. Actually, as per my work is concerned, with these memristors which are given by the CHUA, Professor Leon CHUA, in my tomorrow's lecture, I will design a chaotic generator with the help of the memristors. I am going to design, or I am going to discuss that Professor Leon CHUA has worked on the chaotic theory. He have generated the chaos. He have generated the chaos with the memristors. He have generated the chaos with his basic idea of the memristors. And generation of chaos itself means something. Because like a memristors, chaotic theory also play a very, very important vital role. And then these generated chaotic, when the chaotic signals are generated with the help of memristors, with the help of Professor Leon CHUA, we are going to apply this concept. I am going to share this concept in communication engineering. In communication engineering, in basic communication system, at a transmitter level, at a receiver level. At a transmitter level, we basically modulate the signals. And for the modulation, we applied analog modulation, digital modulation, pulse modulation, and we apply satellite, optical, and all kind of data communication, everything we applied. But till date, we are not able to control the copying of the signals. Signals are stored, signals are copied. As far as security is concerned, in this age of communication, still lot of work has to be required on the security of the data. So what I suggest, when the memristors are able to generate chaos, why don't we use this chaos in a modulation technique? The chaos signals are undeterministic and they are we cannot detect that these are the chaos signals. And it is very, very vague to think that chaos is the chaos is having some valuable signals. And from the chaos, if we modulate it, if we generate a chaos with the help of memristor, when we transmit through the media as a air, it will be very, very difficult for the other party to distinguish whether they are containing a signal or not. Chaos are just like a volcano, just like a very fast winds, just like a tornado. But at the receiver end, these chaos will be received, and with a particular keying, with a particular bandwidth, it can be remodulated, redetected. So the basic idea of work is this, and tomorrow I am going to discuss this memristor concept. What is the application of this memristor concept for generation of chaos, and then we are going to apply the chaos and memristor in a communication system, for a secure communication system. At best, I have explained the memristor's basic concept of the memristor, and I am really thankful to all of you for such a patient hearing, and I welcome for any kind of query if you have any. Thank you. Any question, please?
Looks like we can relate changes to resistance function through memristor. If so, can they be used to detect radiation levels?
Yes, in coming time it is possible. You are right at you are totally right. In my few slides I have proved it like this. What is the difference between the resistor and memristor? Memristor is basically memory plus resistor. It is in dynamic. It is possible. Next question, please.
As India is exporter of titanium dioxide by Kilburn Chemicals, so perhaps India can provide good base to develop memristors, right?
Gentlemen, I fully agree with you. But can you answer my question? If you want to purchase the electronic component, basic component, resistance, inductor, capacitor, where do you go? You go to New Delhi and in front of the Lal Killa. And all these components are from North Korea, Thailand, others. What about the IC's position in India? Where is the nanotechnology in our country? Titanium dioxide, it's a separate issue. We got it, but who will work on it? Where are the facilities? In 2012, I visited USA, Las Vegas. I said that they are in science hundreds years in advance to us. When the Memristor will be fully developed there, then we will start producing here. As per the ICs are concerned, as per my knowledge, I am electronic and communication engineer. I don't think any specific IC is able to, with the perfect specification, is built here in our country. You are right, in the future things can happen like this. Next question, please. Yes, any question, please?
I think that was all the questions, sir. Thank you very much.
Okay, thank you. So nice of you. Thank you.
We'll talk tomorrow, sir.